Good morning or good afternoon, depending on when you see this video. Well, we have a winter storm on the way, as we discussed yesterday. I wanted to create a special video this morning or this afternoon to explain what I am seeing and the changes I made to the forecast a bit and how I'm working with that forecast. So let's dive into the observations that we're seeing right now. And you can see, hey, we're warm right now. We have a cold front that's approaching the region. Temperatures are in the 40s along the coast. They're still in the mid to upper 30s over the interior. We're starting to see some showers being reported. Could see a little bit of snow up here as well, mixed in at times. And that is the leading edge of our polar air mass. Arctic air mass is still back here. So you can see the showers here. It's going to be a showery day around the region. On the infrared satellite picture, you can see the lifting associated with the first cold front, Arctic cold front back here. Here is our storm starting to develop. On the water vapor satellite picture, very, very interesting to see this evolve here because we're starting to see the true strength of this shortwave and how it's evolving and how that's going to start to interact with the polar jet stream and Arctic air mass. And by the way, now you can see the alignment starting to show up very nicely here in the subtropical jet stream and polar jet stream. So everything's coming together, right? So what are we waiting for? Why is the model guidance having a difficult time? Well, it's part of this is the issue with the timing of this Arctic air mass. This Arctic air mass is going to be driving to the coast. There's no doubt about that. The cold air will win. Everyone goes over to snow. Everyone sees snow. The question is the timing here of this Arctic air as this disturbance interacts with this Arctic air mass along the mid-Atlantic coast. So in terms of our model guidance, we're seeing that the European guidance, and you can look at other guidance too, they're all pretty much coming to the same conclusion. Even the Canadian starting to shift a little bit more south and east and moving away from its ultra warm solution, which I never bought. So in this scenario here, you can see the strong shortwave setting up for tomorrow afternoon. And you can see it. Let's zoom in here real fast. See right here, okay? So this is going to set up pretty strong dynamics and strong lifting setting up around the region. And this is going to support divergence and diffluence. You see this little kink right here? This is a sign of convective development starting to show up here. So we're seeing a lot of interesting features setting up a dynamic interaction with the thermal gradient, right? So that's at 500 millibars. And we've been studying the moisture transport. And again, it's not that we're going to get this deep moisture, but we're going to get enough moisture to interact with this Arctic air to allow for the snow ratios to spike. All that remains the same from what we were talking about yesterday. When we look at 850 millibars, this is where things get tricky. This is the 800 millibar forecast. This time is wrong here, but you can see here it's the 1 p.m. on Sunday on the 0Z. And then this is 7 p.m. So this is about 3 p.m. Okay. And I'm going to zoom in on here. And I took away the numbers. All right. This is about 0 right here. This is, let's say, +1, +2. But look at this gradient that sets up. This is intense frontogenesis. And then -6 to -8, that's where this ratio is. So why are we setting up the heavier snowfall in this area? Well, because this is where you're going to have your best peak thermal frontogenesis set up and your -6 to -8 scenario will evolve. But notice we're not far away from that on the I-95 corridor. It's very, very tight. So the coastal plain, this is an easy forecast, rain to snow. Simple. Interior, easy forecast, snow. It's just a matter of how much moisture gets thrown in. The I-95 corridor is where it is tricky. So you Eagle fans out there, you're going to see all sorts of precipitation evolving throughout the game, maybe starting out as a little bit of rain, sleet, going over to snow becoming heavy. I would not be surprised in this type of environment with this type of thermal gradient and slantwise instability in the atmosphere that you see and experience thundersnow in portions of northeastern Pennsylvania, northwestern New Jersey, the Hudson River Valley. Hey, don't rule out the I-95 corridor either, because you're going to have a lot of changes and a dynamic evolution setting up on the surface temperatures. And this is about 3 p.m. tomorrow, okay? So let's focus in on the 06Z guidance here. Let's zoom in on that. And you can see what the struggle here is in the forecast. We're in the upper 30s to lower 40s on the coast at the start of the precipitation. So obviously you're going to have rain. It's a little bit more dicey around the I-95 corridor where we're around 34, 35. So maybe some rain, sleet setting up. This is going to be very close. And when you get strong lifting, these temperatures are going to cool to get to right about freezing. But the difference with this storm and compared to other storms is that this thermal gradient is not going to remain in place, and we're not waiting for the storm to pass us. Instead, just an hour later, the freezing line is passing Philadelphia, driving into central New Jersey, and temperatures are rapidly falling along the coast. And by 5 p.m., you're talking about the freezing line already reaching the coast. And some other guidance is a lot more aggressive in this scenario. So this is why you're seeing on the European, you start off with a little bit of rain and snow here, but then by the evening hours, boom, everyone's snow. So this isn't this case where everyone, you miss out on the coast, don't see any snow. Everyone changes to snow. The question is, how fast does it happen? And so when we study something like the NAM guidance, this is the 12Z. This just came out. This is about at, let's see here, roughly about 12 p.m. I'm sorry, 11 a.m. And there is our progression by 1 p.m. So the NAM is a lot more aggressive in setting this up. So how do we deal with this with a forecast out? How do we explain this to you so that way you understand what to expect? Well, this is why when you're creating a impact map, you don't just try to be perfect. You try to give everyone the potential of, hey, look, what are the outer bounds? What are the areas of that are most likely in this scenario? And then you explain those two sides, and then you include that in the forecast. So we'll start over here, over the interior, far northern interior, to the northwest of Scranton, out towards Williamsport. Why am I going 1 to 3 inches here? Because your moisture transport can only go so far west. Yes, your snow ratios will be crashing, probably 25 to 1. That's how you probably get your 3 inches at most. But the main event is to your east. The 3 to 6 inch range here, we adjust this a little bit further west to include a little bit stronger moisture transport into the region. Again, 3 to 6 inches of snow. The reason why you're not going over 6 inches in my forecast here is because the best dynamics are to your east again. So Scranton, you're right on the edge of that. Hazleton, you're on the you're within the heavier zone, but out towards Harrisburg, I think the best thermodynamics and the best lifting factors are going to be to your east. But you're still going to get a pretty good moderate snow out of this, and the snow ratios could push you up to 6 inches. Now, your high area, I am not as confident with the 10 inches here. Okay, I put it in there because we do have sign of convective snowfall, and there could be some shenanigans. I think a lot of people are going to be in that 6 to 8 inch range with this type of snowfall setting up. So in this area, you got the cross section of the coldest air, the best lifting, and plenty of moisture to work with. So this is where you get your 6 to 10 inch snowfall setup in this setup. Now, here is where the forecast gets tricky. Wintry mix to snow. You're definitely going to snow. There's no doubt about that. The question is when. So we're shooting for about 5 p.m. If it's earlier than 5 p.m., a lot of places are going to be around that 6 inch mark or could even overperform in this forecast. Okay, because you start to then enter into the zone off just to your west here in terms of timing and influence. But it won't be as high as the locations to your northwest because you're still dealing with a mixing issue at the very start. If it takes longer, most likely you're going to be holding around 3 inches. Now, while this is all happening, your snow ratio is crashing because your Arctic air is coming in and your temperatures are falling from the 30s into the 20s. And in the upper levels, you're going from about -1 degree Celsius to -6 degrees Celsius. So that's how your snow ratio keeps on rising. So there's no doubt there's going to be accumulating snowfall in these locations. The question is, for Philadelphia, New York City, portions of, let's say, southwest New Jersey, Vineland, central New Jersey, Freehold, Monmouth County, Trenton, up towards New York City on the shores of Connecticut here is how fast is that changeover. The faster it happens, the more snow you'll see. The longer it happens, the more likely you'll be around 3 inches. And in the coast, it's the same idea. Just we know it's going to take the longest to change over to snow in these locations, and we're starting off at temperatures in the lower 40s, let's say 40, 41, falling through the 30s. So it's going to take time. You start off as rain, go to rain, sleet, then finally over to snow. You will go over to snow. I'm thinking somewhere around 8 p.m. If it's at or a little bit later than 8 p.m., most likely you'll get your 1 inch. If it's earlier than 8 p.m., you're going to get up to that 3 inches. So that's generally the idea. The goal here is I don't want to make 16 maps every time a model guidance comes out. You know what the high end is, you know what the low end is in this scenario, and you know what the factors are. You're having cold air cascading down towards the coastal plain. So now you can make determinations of travel for tomorrow, plans for the Eagles game, whatever, without having to worry about every model shift as we get closer to this event. Naturally, tomorrow we'll have live coverage. We'll see how this storm evolves. We'll keep an eye on it, and then we'll go from there. But I think that's the best way to go about this forecast as we watch the storm evolve. So I hope everyone enjoys their Saturday, and as always, stay safe out there.